So we need to start 4.9b today. In the first part, we were just solving equations by looking at the graph, finding the zeros, and breaking them down. In 4.9b, we're doing two things. And the first one is we're going to use an equation, an actual function definition, in order to find the zeros for that function, which is very similar to what we were just doing. But we're also going to do it backwards. We're going to use a list of zeros in order to write or find the equation for a given polynomial. So the first one is basically a review of what we did in 4.9a. I mean, it looks a little different because it's not an equation equal to 0. It's an equation that's defined for f of x, but otherwise it's the same. And then I'll show you an example where we use the zeros to write the equation. So my first example here, f of x equals x cubed minus x squared plus 2x plus 4. I have already graphed it in my Desmos window here, which you should see in the corner. And I see that there's only one zero. It's at -1. So the first thing I'm going to do is use synthetic division. X cubed, -1x squared, 2x, and 4. I have no missing terms. I don't need to put in any zeros. So I'm looking at this, then I do 1. 1 times -1 is -1. -1 and -1 is -2. Makes this +2. Add to make 4. Multiply to get -4, and I get 0 here. And that should not surprise us that that is 0. That's what I'm supposed to get. So I just divided by x plus 1. That's my first factor. And my remaining factor is x squared minus 2x plus 4, which in order to factor this in the real numbers, I would need two numbers that multiply to 4 that add to -2, and that's not going to happen. 2 times 2 makes 4, or 1 times 4. There's no way I'm going to get -2. So quadratic formula, which is x equals opposite of b, +2, plus or minus the square root. B squared is 4, minus 4, a is 1, c is 4. Oh, I think I may have done this example. It doesn't really matter. Over 2a. So 4 minus 16. Oh yes, I think this is the example I did yesterday. So that's 2 plus or minus the square root of 12, -12, over 2. 12, negative becomes I. 12 is 3 times 4. The square root of 4 is 2. And the 3 is left behind. I can reduce all those by 2, and I get 1 plus or minus I square roots of 3. I have my real 0 as well. X equals -1. So that's a total of 3 zeros. -1, 1 plus I squared roots of 3, and 1 minus I squared roots of 3. And that's all 3 zeros. So notice we found a 0, we factored it out, and we went from our equation to the factors, and from the factors we found the zeros, which is exactly the opposite of what we're going to do in my next example, number 2, where what I'm going to do is use the zeros to find the factors, and then multiply the factors together to get my polynomial. The most important thing the thing that you might forget that you need to remember is when you have imaginary zeros, they have to come in pairs. So if 4 minus I is one of your zeros, then 4 plus I also has to be one of your zeros. So any imaginary zero you have to include its conjugate, which is the sign in the middle changes. So the first factor then is x minus 4, because 4 is one of my zeros. And then x minus 4 minus I. Don't let the imaginary number intimidate you. It works the same way as the real number, x minus 4 minus I. I recommend parentheses because we're going to have to distribute that negative sign. X minus 4 plus I. Okay, so x minus 4, I'm going to distribute these negative signs. That's x minus 4 plus I and x minus 4 minus I. I also recommend that the first thing you multiply is the imaginary parts, because if you multiply the number by its conjugate, the i's will cancel, and then you have just real numbers. X minus 4 plus I times x minus 4 minus I. So negative I times positive I is negative I squared. But remember, I squared is negative 1, so this is actually positive 1. Negative I squared is positive 1. Negative I times negative 4 is positive 4i. Negative I times x is negative ix. Those are the ones I'm expecting to cancel. Negative 4 times I makes negative 4i. See, those are going to cancel. Negative 4 times negative 4 makes 16, which actually goes over here because this is 1, so this is going to add up. Those are whole numbers. Negative 4 times x needs a new column. X times I is ix. It's going to cancel. X times negative 4, those are like terms. And x times x is x squared, needs a new column. So that gives me x squared minus 8x. These cancel, and that is 17. 1 plus 16. Now I have to multiply this by my third factor, x minus 4. But there's no imaginary numbers anymore, so I just multiply it through. Negative 4 times 17 is 40, and 28 is 68. Negative. Negative 4 times negative 8 is positive 32. Negative 4x squared. X times 17, x times negative 8x, and x times x squared, which leaves me with x cubed minus 12x squared plus 49x minus 68. So there's my answer. This is the polynomial with these 3 zeros. So you take the zeros, you write them as factors by just doing x minus whatever the 0 is, x minus this one, x minus this one, x minus this one, and then multiply them all together to get your polynomial. That's 4.9b. Your assignment for 4.9b, I already put in classroom yesterday. Oh, I thought I did, but I did not. 4.9b, you're going to be doing 4.9b on page 298, 33 through 43 odd. What? That's only 5 problems. 1, 2, 3, 4, 5, 6. I don't need to give you 12 though. 2, 3, 4. Oh, it's 6. That's fine. It's only 6 problems for today. Enjoy.